I bought 10 faulty Nintendo Switch consoles from eBay in the hope of fixing them and selling them for a profit. As you can see, we have a plethora of different faults with these consoles. In my opinion, it would be a little bit boring if they were all faulty, no power. From an orange screen here, which is usually related to the Wi-Fi chip, to a damaged screen, no power, and faulty charging ports. I want you to briefly take a second before we start the video to go into the comments and say how many you think I'll be able to fix out of the 10. And then by all means edit your comment at the end of the video to see if you were right. For all of these Nintendo Switches, I paid a total price of £225. That equates to £22.50 per device. And in all honesty, that's a really good bargain. I'm really quickly just going to label each one in case I need to reference them within the video. So let's have a look at Nintendo Switch number 1. It says it's got a damaged charging port. So the first thing I like to do is check that port underneath the microscope. How are we looking? Yeesh. Yep, we can definitely see here that we have a damaged charging port. There is also some what looks to be like gunk down at the bottom left just there. More like earwax or something, you know? I think it's safe to say we can now take this one apart. What's nice is that this Nintendo Switch on the inside looks relatively clean. It doesn't look to be water damaged at all. And usually the way you can tell that on a Nintendo Switch when you take the back cover off, you've got this sticker here, which is almost like a red and pink. When there's water ingress on the board, this sticker will go a solid pink. So this is good. I like to use my hot air gun here at 160 degrees Celsius just to make sure I don't rip the foam on the heatsink. And finally, the board is out of the chassis. What I'm operating with here, you can see my heat gun just underneath the board. I'm operating with 450 degrees Celsius and an airflow speed of 50%. That's going to be enough to melt the solder from the board, and I should be able to just lift this port up. Just like that. I'm going to put some flux on this PCB. Flux is a magical thing that makes solder flow nicely. And I'm going to take some leaded solder and put it in the ground holes to mix with the unleaded that we have already on this board. What does this do? This lowers the melting temperature. So when I go to put a new one on, I don't have to use as high of a heat, which is better for the PCB. There we go. Give it a real nice clean. Now we're going to grab our multimeter and check for shorts. We've got our multimeter software in the top right hand corner of your screen. This multimeter is in continuity mode, which means that we get a beep when we have a complete circuit. We should have a beep through this fuse, which we do. So the fuse is A-OK. This is our famous M92T36 power management IC, aka the actual fuse. This chip blows a lot more than what the fuse should do. A fuse is used for protection, but a lot of the time it bypasses the fuse and hurts this IC. I'm hoping it's just a damaged port and nothing further. These chips can be quite costly. Let's see if we have any shorted components around this area. Is our CPU okay? Our CPU is fine. Do we have any shorts here? No. This side is going to be ground, which when it beeps is perfectly normal because my black probe is on ground, and therefore we have a complete circuit. If one of these sides was beeping, what that means is that that's also connected to ground instead of doing an important job into the chip, but we look okay. There is a secondary component that we check, which is called the BQIC. This is the battery circuit IC essentially, and along with the M92 is responsible for a lot of the charging circuit. So if we measure on here, do we have anything strange? No, one side of these caps, all of them, is ground, which is exactly what it's meant to be. This chip seems to be all right. So I think all we need to do with this one is simply put a charging port on. And if we have a few like this, it means that it's going to be really good profit. These are the Nintendo Switch ports themselves, and at the moment they retail for around about £1 or so. Not very expensive to actually make a Nintendo Switch work again. Our first job is to put a little bit of flux on the port because I like to tin the contacts on the port just to make sure that this row underneath here actually solders properly to the board itself. Same process as the PCB really. Take a little bit of leaded solder and just glide it across. We're going to give it a clean, and now this port is ready to go onto the board. We now just put the port on like we did taking it off, but in reverse. Tiny little bit of flux and just spread that around. Can you see we've got a row of pins here? These ones you can't get to if you do need to solder, so that's why I use the hot air gun. A little bit of flux here and here. Okay, perfect. Now I'm going to use a temperature of 420 degrees Celsius because again, we've mixed the leaded with the unleaded, which reduces the temperature overall. And we can see now that the solder is wet on the board, so I'm going to come in with the port, keep moving that hot air around, and we should be able to just push it down into place. Now if I give this a slight push and come off the heat now, that should all solidify nicely, and we're going to check those pins. But before we do that, a quick clean needs to be done. Wait for that solder to harden. There we go, just to make sure. When flux is hot, it's the easiest thing to clean. When it's dry and cold, it's horrendous. Looking good. What we look to have here is a little bit of, I don't know, maybe thermal paste that has just creeped into the actual soldering part, but that will be absolutely fine because it's non-conductive, so it doesn't really matter. Hopefully, it's not got in the way of these pins being soldered. Every single one seems to be absolutely solid. Port is nice and flat to the board itself, and we've done a good job on the back. Also, all that's left to do with this one is simply give it a test. All I've hooked up here for testing is a couple of screws, the backlight ribbon cable, and also the LCD ribbon cable here to see if we get an image. So let's do exactly that. Let's plug the battery in as well. 3, 2, 1. Here we go. That's really good. 120 milliamps down to 0.07, and yes, we have a battery icon, which essentially means that this unit is now successfully charging. 100 milliamps is actually quite low, and the reason being, this switch might have been off for 6 months to a year, even more, maybe less. And when the battery is completely drained, it can only take a certain amount of amps. And when it's fast charging, it could go anywhere up to 1 amp. Hopefully that's all this Nintendo Switch needed, and we're 1 for 1, but I'm going to need to let it charge in order to test. I will mention it's very kind of the seller to actually outline the issues with these Nintendo Switches. That has saved me a bunch of time. For each of the Nintendo Switches, I'll be testing them off camera. It's not necessarily the most interesting content, but it will include all the necessities. I'll be testing the Joy-Cons, the touch screen, the Wi-Fi, the game card reader, make sure it charges both ways, the SD card reader, and also make sure that the Joy-Cons are actually charging. Oh, and also making sure that it works on a docking station. 1 down, 1 fixed, and 9 to go. Let's move on to switch number 2. This one is a damaged screen. Now, these ones could probably be the most costly depending on whether you've got donor parts that you could potentially use for free, or where the cost is associated, you have to buy the actual screen itself. In my circumstance, it's a lot cheaper to migrate all of what's here into another housing and just transfer the serial number that we have. But nothing is as simple as it seems. So let's just double check and make sure that it is only a damaged screen. It's not turning on, is the first thing I'll say. Let's actually give it some juice and see what happens. Here we go. Okay, something, which is good. 110 milliamps down to 0.07. Yep. Okay, so we have a charging symbol. That's good. But what do they mean by damaged screen? Could it just mean that maybe the digitizer's gone? Again, I'm going to have to wait for this to have some charge to then give it a test before we go ahead with the repair. I'll use this opportunity to say, if you haven't subscribed to the channel already and so far you like what you see, please consider doing exactly that, because I'm trying to hit 100,000 subscribers by the end of 2024, which is a silly goal, but nonetheless, we're going to give it a go. Okay, we finally got a little bit of life, but it looks like it's been reset. The screen looks okay, hey? I mean, I can't see anything wrong with it, unless it has to be touchscreen. What? The touchscreen works. That's very strange. I'm going to go through the setup and see what the situation is. Let's just test the touchscreen functionality of the screen here and see if it was maybe the digitizer itself. It's not losing connection at all. So it seems to be absolutely fine. That was just because my finger slid off, but there's no dead spots or anything. Strange. Let's test it in a docking station. Maybe that's what they meant by damaged screen. Here we go, plugging it in. No. Sometimes I need to turn this around to make sure that it's okay. So let's try that. Is it still on? It is. So I'm going to turn this around. See if it works now. I don't understand. Everything seems to be working absolutely fine with this Nintendo Switch. I'll just go through and test everything, but maybe we've just got insanely lucky with this one and it was put in the wrong pile. I've done pretty much everything testing-wise and it's working with no issues. Absolutely fine. I'll leave number 2 on charge until the end and then I'll revisit it just to make sure that the battery goes up to 100%, etc, etc. But for the time being, I've done all the testing I can do. I've even given it a little bit of a wiggle to see if any bend will create a blue screen or anything along those lines. And it seems to be working. Let's move on to switch number 3. This one is a no power, and no power could mean absolutely anything. The ones that are labeled saying that there's a damaged charging port, I'm assuming the no power ones don't have a damaged charging port. Just to completely eradicate the potential for a bad port, that looks really clean, hey? That looks really, really clean. Almost brand new. In which case, let's again use our ammeter. I didn't actually mention yet, this little device tells you what current is going through into the Nintendo Switch. If you're interested in purchasing one, I'll leave a link down below in the description. It will be affiliated. Here we go. What happens? It felt a little bit iffy going in. 0.09, 0.06, and we get nothing on the display. This one is shouting to me that it's going to be a little bit tough to resolve. I've got a feeling that the battery's very, very dead, which is why it's 0.06. However, we should have a battery icon here to indicate that something's going on, and we don't have that. Maybe we have an issue with the actual screen itself. It's got potential. Clearly, it's not doing what it should, so let's take it apart. The good news about this so far is that if you recall what I said earlier, we don't seem to have any liquid damage. I've just plugged in a known working charged battery because the other one was really flat, so I want to see what happens if we do that. What do we get? Ooh, 180 milliamps, which is definitely not a good charge. I think we have a short on the board. Under the scope again, what I'm going to do is just go around the board to see if I can have a look over our usual suspects and see if we've got a shorted component anywhere. I think I might have found the issue, but I could be entirely wrong. Here I have a thermal camera. Now what this does is it detects heat on the board, and any components that are getting above a normal temperature will show up red. And as you can see on the board right now, right in the center of your screen, we have a component that's reaching around about 28 degrees Celsius, which in the grand scheme of things isn't that bad. But this little component is called the fuel gauge. Directly behind the fuel gauge, we have the BQ IC, which as you can see is also getting hot, but this chip does get hot around about 30 degrees or so. I reckon our issue is the little fuel gauge IC just about here. So I'm going to swap that out. There are no other shorts on the board, no other signs of heat, nothing. But what's not normal is that we're drawing 3 milliamps, which is literally next to nothing. However, it should be 0 because we don't have any batteries connected. If I turn this around and do it this side, we have the same story, about 3 milliamps. As you can see on your screen right now, this chip is tiny. Here is my fingernail for reference, and that is the chip. I need to remove this one, reball another, and then put it back onto the board. I've looked for shorts around the area as well, and there's no shorted components. So this is a pure guess. A drop of flux, take our soldering iron and just clean this area up. Let's take this one from a donor board and reball it. Tiny wincy bit of flux there, and use our soldering iron to clean the chip. There we go. And now we reball. Coming with our stencil just there. Tiny bit of solder and reflow. There we go. Now we put it on the board, a little bit of flux just there, quite a lot, so I'm going to dab some of it away. Pin 1 on here is the little plus sign. This is the right way. Now we just hold it in place and try and put it back. Tiny bit of flux around the IC. Definitely not sat correctly, so I'm going to do that again. Hopefully that one's gone a little bit better, a lot more flat to the board, and it looks like the solder balls underneath are connected, although a little bit fluxy. Let's see if that's made any difference. Plug in the ammeter, here we go. What do we get? 0.11, 0.06, and nothing on the screen. So exactly the same, no change, even though we've changed out the fuel gauge. So this, I've confirmed this battery is actually full, and for whatever reason, we get 190 milliamp draw. I've put my thermal cam over, and I can't see any heat except for the BQ chip on the other side. Now, I'm actually just going to guesstimate here and try and change out M92T36 to start with, and then worst case, we'll change out BQ. Let's go. Again, 420 degrees Celsius, airflow speed 50%. Make sure it's all soldered correctly, which I have faith, I believe it is. Looks all good to me. Do we have a change in behavior? Battery plugged in. What do we see? 460. Straight back down to 19 again. So the exact same behavior. I'm going to change out the BQ IC. A little bit of a different technique for this one because we need to do it from underneath the board. And the reason being is because we've got a bunch of plastic on the same side, so we can't use hot air. Again, make sure it's soldered correctly. Looks good. This side looks good as well. Nice. Any change? Okay, what do we have? Do we still have 190 milliamps? Let's see. 460. No, it stays at 460. Was it the BQ then? Okay. Let's plug it back into the chassis and see if we get a battery icon. Moment of truth, and I'm pretty hopeful considering that it now stays at 460. What do we get? Do we get a battery icon? 110, 0.06. This is on the console battery, by the way, so this is indicating that it's completely flat still. And the bad news is that we still don't have a battery symbol up here. I'm going to go for one more chip, and that's the P13 USB chip here, this long one. This is responsible for the video output on the device when we put it into a docking station, etc. Has that made our difference? Probably not, but we're going to give it a test. This is it. Putting it in, what do we get? 0.12, 0.06, and we get nothing on the screen. So this Nintendo Switch, unfortunately, we're going to call it not fixable, which kind of sucks. I would just like to confirm as well. So this is a donor chassis. I've transplanted it into this one, just so then that way we can disregard the actual screen being a fault. I'd be very surprised if that was the case, though. What do we get? 0.24. Yeah, 0.19, exactly the same thing. Just turn it around, see if we get the battery symbol, which we don't. So I can 100% confirm it is the Nintendo Switch motherboard that's at fault. Any that I'm not able to fix that's maybe a little bit too long for the episode, I will be looking at in some live streams. I could spend more time changing out a few more chips, but then this video will go on for I don't know how long. With that being said and a haircut achieved, let's move on to switch number 4. The dreaded orange screen. This fault is usually caused by a bad Wi-Fi IC. Let's just make sure the device actually powers on, because we have been finessed before. Allow me to show something. 110 down to 0.09, and we get a nice charging icon. I'll be back when I can replicate the issue. We have 16% battery on this device now. It's turned on, which these switches usually do if it's an orange screen. It can be very, very temperamental. So I'm going to try and connect to the Wi-Fi. I've managed to connect to the Wi-Fi, no problem at all. Let's try and update the device, because that can sometimes cause the issue. Update's gone through, seems to be okay. I'm going to go for a system reset, which again has triggered that orange screen for me in the past. Now you can get away with just reflowing the Wi-Fi IC, because sometimes it's just the solder balls underneath that have become a little bit cracked, which affects the connection between the chip and the PCB. And reflowing that will recreate those connections. But personally, I just like to replace the chip. Who knows, maybe we might not even have to with this one. Potentially misdiagnosed. I'm just really hoping that I can replicate this orange screen. The factory reset has gone through. I connected it up to the internet. I've gone onto the Nintendo eStore. I've tested everything else in terms of games and everything, and for some reason I can't replicate the orange screen fault that we have on this one. I can only obviously spend so much time testing a device. I think the best thing to do here in my interest is, instead of completely changing out the chip as I previously suggested, it would be best if I took the device apart and just reflowed the Wi-Fi IC in case there is a bit of an intermittent issue there. There's no point in me replacing it if I can't duplicate the orange screen fault. Hopefully we have another Nintendo Switch that's an orange screen, and I can show you the full process of actually changing out the Wi-Fi IC. This is what the Wi-Fi IC looks like. It's a very, very shiny IC. Now all I'm going to do is simply heat this up with around about 420 degrees Celsius, nothing too drastic because I don't want to destroy the chip. Put some flux underneath and then just give it a nice little reflow, and then also a thorough clean out. Do extractor on, because health is wealth. That's enough. Just a simple little tap like that, and then a nice clean. I decided at this point to just go through the factory reset process again, just to make sure that we didn't get any orange screens, which we didn't, and of course the device is working perfectly as normal. I'd consider that extremely, extremely lucky. Let's move on to the halfway point, Nintendo Switch number 5. Ooh, lovely jubbly, we have a damaged charging port. Straight on over to the scope then. Whoa, whoa, whoa. Hopefully we don't have any further damage on this one, considering they're all holding hands, it looks like, those pins. One thing I have failed to mention in this whole thing is that the Nintendo Switches themselves are in fantastic condition all round. No screen damage other than the ones that have broken screens, and previous techs definitely haven't been inside them before. So I'm extremely lucky with this specific lot. Let's get this one open. Again, what we're going to do is pull the port off first, and then we're going to check around the board for any shorted components. Again, maybe M92 or BQ has become shorted. Hopefully not, and it's a nice easy fix. Nice one. Continuity mode again. Let's make sure our fuse is all good. So again, we're looking for that beep. We get that beep, which shows continuity. M92T36, how are we looking? All good around here. BQ, all good. Quick board inspection just to make sure we're all okay. No shorts or anything visible on the board. Let's get a new port on. And this is a great example of a port that's not sat down correctly. So I need to just make sure you see how none of these are connected to the board. So I now just need to reflow this quickly. And you can also see how this solder hasn't gone all the way through. Much better. Sometimes these ports you can get away with just a reflow. Other times you need to take out the port, because it could be, here's a little inside tip, sometimes the plastic on these little legs melts and it doesn't fit through the board properly, which causes there to be a gap between the port and the pins on the board. But this is looking okay. I've just checked them on the other angle, but yeah, this looks fine. Nice. Let's give it a test. There are 100 different ways to test this port. As you saw on the previous ones that I've showed, I've just been plugging power in after I've made sure there's no shorts and using the ammeter. But we do have this, which is a little USB-C reader tester. And if I go ahead and plug this in, what this is going to do is test all of the pins and make sure that they're all connected. And yes, that does say teasing instead of testing. There we go. All green on the ones that need to be green. So this port is A-OK. That, however, doesn't guarantee us that we're not going to have any other issues with the charging circuit or the board itself. All green is nice, but there could be other issues. Moment of truth. Here we go. Do we get a display on the screen? We get charging, that's good, 0.07, and we get a display, wicked. I'll be back after testing, but if we have managed to fix this one, so far at the halfway point, we are 4 fixed out of 5 with a broken screen that there was nothing wrong with, and the orange screen as well with a little reflow. But I'll take those numbers so far. I'll try not to get too ahead of myself. Good news, I've tested everything there is to test on this console and it is fully working. I'm literally just going through the factory reset now, so it's all cleared and ready to sell. It's time for Nintendo Switch number 6. Interestingly, it's a no power. The last no power we had I wasn't able to resolve, so hopefully we can sort this one out. Let's check this charging port. I'll allow. Again, very, very clean. Ooh, what's that? What are you down the bottom? Just here. Oh, you're off now, so that's good. Plugging it in to the ammeter. What do we get? Because we don't have any bent pins or anything, so I think it's going to be okay to test. All right, 0.07, 0.09, and again we have the same issue whereby nothing displays on the screen. This is not good. When this battery is charged, again, it will sit around 460, 470 milliamps, but we're not going to get anything on the screen. And it could mean a plethora of different issues. So let's take this one apart and inspect it. We have signs of corrosion. Corrosion is never good. Even though this hasn't gone a full pink, we can see corrosion on the battery down here. And I think I can see a little bit of corrosion just on the pins of the charging port. But other than that, it doesn't look like it's been submerged underwater, which is always a nice thing. Let me take the motherboard out and see how bad this corrosion is. This is the back of the board, and we can see the P13 USB. Remember I told you, responsible for the video output. That's been hit pretty heavy with some corrosion just there. We've got the liquid here, but it's dried up now. And if we go over, we've got some more corrosion down here, just in and around this IC as well. I'm going to assume underneath the IC or not. Maybe okay beneath the little fuel gauge IC here, or maybe I can see a tad bit of corrosion. This is the battery connector, which can just be cleaned. That doesn't look too bad. Take a look at BQ. Yeah, wow, we've got quite a bit of damage around here, haven't we? This cap has seen better days. It might be okay, though. It might have just been caught in the crossfire, essentially. I mean, it seems to be okay, as in, if I try and put some pressure on this, it's not pinging off, which is always good. This one looks a bit worse for wear. Yeah, that one's gone, look, and that wasn't a lot of pressure at all. That one's just come off. This one, again, seems to be okay. BQ might be all right, this little resistor. Is that? Yeah, that one's gone. Okay, so that little resistor will need replacing as well. I'm just thinking, is it actually worth it when it comes to this level of liquid damage? It doesn't look like it's corroded the board, you know? Potentially down here a little bit, but if I was to take BQ off and refresh the pads a little bit, would it resolve what we have going on here? Most probably. Same with the actual coil itself. I would just look to replace that. Hopefully, the pins underneath the charging port here are okay, because once these become corroded, it increases the likelihood of damaged traces, and that's where you start introducing trace repair, which can be very timely. But we can see one pin that doesn't look great, does it? This one. Let's have a look around. M92 T36, surprisingly okay. No signs of liquid damage here, which is nice. Max IC is another usual culprit for some liquid. Yeah, look, we can see all the liquid damage here down by this coil. Again, hard to see if any of it has gone underneath the IC. Does look like it, doesn't it? Does look like a little bit of corrosion inside that Max IC. And then we've got all these connectors as well. Yeah, these connectors are done for. So they will need replacing. To be honest, again, I think you could probably get away with just cleaning those, but I don't know if the trace underneath. Can you see this like black char almost just here? That to me screams that the trace underneath is damaged. And we've got the same here. So this is the backlight connector, which has corrosion, and this is for the right Joy-Con. Did any of it go around or into the NAND? Because if so, that is an instant game over. Doesn't look like it. Down there looks pretty clean. Underneath the NAND, yeah, whoa, look at this. Pure rust on that metal, especially on this little IC down here. Over to the back of the board, yeah, more corrosion here, look. That is a BGA as well, this little chip. I think this is the backlight IC, so I've just popped the shield off. The RAM actually looks all right. Doesn't look like there's any liquid ingress around there, as well as the APU. Ooh, we have a little bit of rust here. We don't know what it's going to look like underneath the APU itself. And again, just more damage here, which was on this pad, which leads to the APU. I think I've had my verdict on this one. Unfortunately, I don't think we're going to be able to fix it. If I spent enough time and effort, I'm sure maybe we could get it up and running, but even at that point, if I was to fix it, I wouldn't feel comfortable selling it on to somebody else, because a couple of weeks down the line, a couple of days, even potentially a couple of years, it's most probably going to fail. The liquid damage on this is a bit too much. Also, I've just had a look. The chassis itself isn't going to be any of use. This is the backlight. This is one of the rails for the Joy-Con, which can be replaced. That's not too bad, but the backlight is bad. LCD is fine. Digitizer is a little bit worse for wear down here. And obviously we have some corrosion down in the battery, which again, this isn't too bad. That can just be cleaned out. But purely for the sake of the backlight, I'm not going to be able to use this, unfortunately. So we'll have to count that one as a straight loss. And there's no point in really trying to sell that as faulty because of the water damage on the board and the chassis. It's a shame, but let's move on to switch number 7. Lo and behold, another damaged screen. I've actually given this one a little bit of charge, and I can confirm that it does power on. Now, am I going to get as lucky as the previous one? And the only reason I'm saying that is because I have two little marks on the screen here that when you turn the screen on, they're barely visible. So I don't know if when they say damaged screen, they're talking about these little teeth marks, perhaps from like a dog or something. Because honestly, other than that, it's not in horrendous condition. It's not as good as what the others have been, but it will still sell for a pretty penny. I'm just going to take a look deeper at that charging port, even though it says damaged screen. Oh, okay, fine. Yeah, well, that charging port is going to need changing because eventually, even though I've been able to charge it, that is going to break. Look at that. Can you see the bend down here? And there's a bunch of gunk down here as well. So this could really benefit from a clean. Don't think it's been opened before though, looking at the screws. Whilst I've got it fully assembled, I'm going to give it a test now just to make sure we're all good before I then go and spend time replacing the port for no reason if it's broken. Just to also confirm, this screen is working absolutely fine. And it works on a docking station. Wow, this switch is actually really dusty as well. So maybe it does just need some TLC. And of course, a little check on the pins, make sure they're all soldered, they look it. Lovely, jubbly. Giving this a nice clean out with an air duster. Just putting this one back together, and I'm actually contemplating whether or not to put it in the chassis for number 3, but this is the one we couldn't fix. I will be looking into that later, so I think I'm going to need this anyway. And we're now back on. I just want to confirm that we charge both ways. That would be good. Thank you very much. Yep, 450 milliamps are going to bump up to the fast charge. Oh, it's not going to because it's full. It's full battery. Turn it around on this side as well. How are we looking? Yeah, all good. Charging both ways. Wicked. Yeah, I do think it is the damage on the screen that is the only reason why they put this as a damaged screen. We've changed the port regardless, which is nice to know. This is going to be running for years to come. But again, all tested, all good. Nintendo Switch number 7 has been fixed. Time to move on to Switch number 8, and hopefully we can end the dry streak of not being able to fix no powers, because number 8 is exactly that, another no power. 2 of the previous no powers I haven't been able to fix. That ends now. Over to the charging port just to confirm. This one doesn't look like it's had any corrosion or liquid down the bottom of it. This looks super clean, like brand new clean. And I'll mention the actual switch looks brand new. There's hardly any scuffs or anything. It's a really, really good condition console. Now, please do not show me nothing on the screen or just something else different to 460 milliamps or 0.07 on here. Please, something different. Here we go. Come on. Let's do this. Please, please, please. 0.13, it's going to do the same, isn't it? 0.14, okay, still nothing on the screen. That could be a short on the board. 0.14 is different to what we've seen with the previous two. So I'm gonna keep my faith up here. Let's take this one apart. I think this one is faulty from factory, and the reason I say that is because I've never seen thermal paste so perfect on one of these devices. Down to the nitty gritty of this board then. So fuse is good. Yep. M92T36. Any shorts around you, my friend? No. M92 all good. BQ. No. Is that liquid damage there? No. This board is really clean. Really, really clean. Wait a minute. Do I see a pin pushed down on the LCD connector? Can you see that? So this is me checking inside the LCD connector. And there is a pin just here that looks a bit south or north, depending on how you're looking at it. That can't be the only issue with this one, can it? Try and get it back in the right place. Is that the only one as well? Yeah, it does look like the only one, doesn't it? I'm actually going to have to use a sharp blade here. There we go. I think that'll be enough, you know. And then the way I'm slowly and carefully going to put this back in is by putting in the ribbon cable first, like that. And then maybe we've got really lucky with this one. Here we go. Was it that simple? Just a loose pin on the FBC connector. What do we get? We get 120 milliamps, 200. Nothing on the screen. Okay, so that hasn't fixed it. I wonder if the backlight is on. Oh, it is. The backlight's on. So this switch will work, right? It is just a FPC connector, I'm assuming. If I take this dummy battery here, which is full charge, we're not going to get a display. But I wonder if we'll get something on the docking station. There we go, 470. Do we get a backlight? We get a backlight. Is it turning on? Bump up to fast charge. There we go. The Switch is booted. Yeah, it's charging. It's fast charging at 830 milliamps. We just don't have a display. And I can confirm that by putting this in, going over to our game scene, and there we go. The Switch is on. So it's a display issue. It's not no power. I think I'm going to have to replace the FPC connector. So I'll show you how to do that now. That's an interesting one. At least I think it's going to be the FPC connector. I can't see anything else wrong with it, to be honest with you, other than the one pin out of place. There must be a reason why we're not getting a display. Let's find ourselves a reasonable donor for the job. This one is actually from the water damaged Nintendo Switch that we had earlier, and to be honest with you, it looks fine inside. So I might as well just use this connector. Lovely. As I said, I don't know if this is entirely the issue, just it being the FPC connector, but we can clearly see a little bit of damage on it, so it makes sense. This is the donor that we're going to take off nice and smoothly, and I do that by heating underneath the board at 450 degrees Celsius with an airflow speed of 50%. There we go. Now we take off the one from the board that we're working on. Tiny bit of flux here because we're going to go over these pins with leaded solder to make the melting temperature lower. So flux and then over them just like this. Nice and smooth. There we go. Wicked. Now I do want to try and move quick here whilst the board is still hot. So let's just clear up some of this flux. And then I'm going to come back in with some more flux, but not too much this time. And again, just dab up the excess that I think we can take out. There we go. Get the new connector in some sort of position, which I feel like is about there, and I think that is going to do the job. So now again, we go underneath the board. We can lower our temperature here a little bit. So we go 430 at 50% still, and now we'll just try and reflow that connector in place. Right, that looks good to me. All looks soldered. I will confirm though. I actually think it could do with the softest touch down south a little bit, which is going to be really hard because this is almost in mid-air. I think that'll be enough. I think that's in line now. And now all that solder has solidified, in which case we should be able to come in with our cotton swab here and just clean up the flux whilst it's hot. Okay, let's check it. All of those pins look soldered to me, which is nice. Check the other side now as well. Yep, all of those look soldered. Okay, and the connector itself looks okay. Let's see if this works. Bare basics plugged in to see if we get a display. Let's see what happens. Here we go. Come on. You give us a battery symbol. Yes, let's go. Okay, sweet. That display is now fixed. And this is just, this 210 milliamps is just low battery. Lovely. So we'll let it charge, get it all back together, and give it a test. After a nice clean and a full test, this has been factory reset and is ready to go. Everything works with this device, and it is spotless. Take that. No power. Out of the 8 Nintendo Switches so far, we have fixed 6, which isn't a bad percentage at all. But it all boils down to these last 2. The faulty, to be tested, orange screen? Question mark. As we know, the previous orange screen wasn't fixed because I don't think there was anything wrong with it to start with. But we reflowed the Wi-Fi IC just to make sure. Can we replicate the actual orange screen on this device, or are we going to have another case of we can't get it to show? The fact that this has a question mark worries me a little bit. So let's see what the situation is. It turns on. Fine. There's a game on here called Dauntless. I've never heard of that personally. Let's try and connect it to the Wi-Fi. Wi-Fi is all connected. I'm going to go ahead with a system update. Update. Okay. Update's gone through absolutely fine. Doesn't seem to be any issues. I'm just giving the device a little bit of a bend if I can. Again, I'll put it through its paces and make sure that everything else works with it. Yeah, game card reader works. Joy-Cons all good and are charging. I know it sounds silly. We're going to go for a factory reset though, because again, that can sometimes cause the orange screen. I've reset the Nintendo Switch and it's currently just downloading some data for a game that I've put in. But I can't force it to orange screen again, regardless of a system update and an actual factory reset. So I'm just going to sit here for 10-20 minutes and play it and see what happens. I can't replicate the issue. And like I said, the fact that it had a question mark really makes me think that they weren't too sure that that was the fault. It was maybe just returned. I think with this one, again, it's more so just going to be a case of taking it apart and reflowing the Wi-Fi IC just to make sure that we don't have that issue going forward. Like I said previously, it doesn't always resolve the orange screen that appears on the Nintendo Switch, but I can't force replicate it, so I really don't see any need to change out the Wi-Fi IC based on a previous sticky note anyway. So I'll just go ahead and reflow that IC. I'm not going to show you again because I showed you a couple of seconds ago, but I'll be back with you to test afterwards. Here we are, and again, I've given it a nice clean. It's had a reflow, and it looks pretty much brand spanking new. I'm just going to go with another factory reset here just to make sure that everything is actually okay, and then I guess we can call this one good. Let's move on to our 10th and final Nintendo Switch, and hopefully we're going to be able to go 2 for 2 on the no powers. Wish me luck. Let's head on over to the scope to just check this port. Ooh, I don't know if that is potentially a little bit of liquid damage on that charging port. It looks a little bit crystally or something. I don't know. I see some glistens, which is never a good thing, but that looks okay to plug in the ammeter. What happens? Oh, this one has a screen protector on as well. Great condition. What happens? Okay, I like this. I like the look of this. You might be thinking, what, Joey, what are you talking about? Nothing's coming up on the actual charger. But what that may indicate is that we have a different fault. It could be something like a faulty M92T36 or just a shorted capacitor on the board. Either way, let's open it up and take a look. Hopefully not liquid damaged. Okay. Oh, we have a little bit of a mark on BQ, but I think that's just a spot of sweat, to be honest. Is that sweat? Yeah. Water damage indicator, absolutely fine. Let's check our fuse. Continuity mode. Do we get a beep? No. Oh, wait. Okay, all right. It was playing me up. Fine. I remember that. Also very convincing that that could have been the issue, especially because the ammeter itself was completely blank. Let's check over M92T36. Seems to be okay. Do you have a little bit of a marking on this MOSFET up here? I'll bear that in mind. Check around BQ. Again, A-OK. This is a weird one. Visual inspection of the board. We look all right. Again, no water damage anywhere, which is nice. Fuel gauge looking really, really clean. P13 USB, not an absolute mark on it. All over here, the backlight chip, etc. All looking okay. This is a strange one, hey? I like it. Remember I told you about my little mechanic USB-C tester? So I'm going to plug that in now and see if it registers all of the pins on the actual charging port. Because even though they look okay, maybe we've got a bit of a dodgy one. Ah, number 5. Okay, 0.07. So we have a short on this rail here. Can you see? And this is not good. So we have a short somewhere. We just have to find it. That's probably going to be on the pins underneath. I'm pretty sure it's here. So we've got 12 ohms here, which isn't our short to ground, but I just need to know where this goes. Where does that go? We don't have schematics, unfortunately, for the Nintendo Switch. Okay, so I might have missed it, but on this cap here, we actually have 9 ohms. So I don't know if it's going to be M92T36 or whether it's going to be the cap itself, but 9 ohms is not good. Take a donor that I have here. On this cap specifically, we don't get anything. We just get open line. If I put this into diode mode and measure, what do we get? 0.49, ignore the beeping. If I measure into this cap, 0.039. Yeah, so this is where we have our issue. I think it's going to be M92T36. So I'm going to take a swing at it, take it off the board, and then remeasure that cap. Let's measure in continuity mode on the cap, make sure that we're all good. Yeah, open line, look at that. So I believe it was M92T36. And the area we had a short before, which on here was B5 on the port, but on here, this is where that went to. And that's showing us open line now as well. So I think we just got to replace M92. Lovely jubbly. We said that we maybe just a simple M92 fix. Now I'm taking another M92 from the water damaged Nintendo Switch that we had earlier in the video. So again, it's just I'm harvesting parts. I'm using that board for parts, and I've managed to fix 2 Nintendo Switches for the simple cost of the £22.50 that I paid for it. Even though it was water damaged, these chips are absolutely fine, and so is the FPC connector. So we put that there. Get a little bit fluxy. Nice clean, don't be mean. Like nothing ever happened. Sweet, let's measure this cap. Short still be gone? Yeah, no short. Measure in diode mode. Ignore the beep. 0.43, perfect. And if we put our little mechanic tester back in, again, I'll leave a link down below. It will be affiliated for this little device. It's amazing. Teasing. What do we have? Has that short gone? There we go. All greens, look at that. Lovely. Jubbly. Let's put it back in the chassis and just see if this Nintendo Switch works. We get something on the ammeter that's good, 0.11. What do we get up here? We get the charging symbol. That's what we like to see. I've now just finished testing everything with this Switch, other than just doing a factory reset, and it's all good to go. We are done. I have managed to fix a total of 8 Nintendo Switches out of 10, which gives us an 80% success rate. One of them was completely written off by water damage, and the other one, hopefully, I'm going to be able to fix on a live stream, perhaps. I'm now going to run you through some interesting stats. Firstly, I'm going to show you how much profit I would have made if I go to sell the Nintendo Switches. After that, I'm going to show you how much I would have charged for each repair and see which one made us more profit. So total cost for them was £225. Now, believe it or not, the only parts that I used in this that I paid for would have been the charging ports, which are valued at £1 each, and I used 3 of them. So that equals £3. The FPC connector was taken from a donor board. The M92s were taken from a donor board. Anything else would have been taken from donor boards from this specific job lot as well. This will also incorporate eBay fees of around about 9%, which is how much I get charged for my listings. Now for sell price, 7 of them are in great condition. So I think I'll be able to get about £90 for each of them. There was only one that was in a slightly worse condition, and I would probably be able to get £85 or so for that. So that brings our total sale price to £715, and our gross profit from 10 faulty Nintendo Switches is £422.65. And I've just gone through each job and worked out how much I would have charged. For example, the water damaged one, I wouldn't have charged anything. For the ones where I had to just reflow the Wi-Fi IC, I would have charged £25. FPC connector replacement would have been 60. Charging port replacements would have been 60. So that gives us a total of, if I was to do this as a service and they were jobs that came in, it would be £385. So actually, for once, selling has worked out better. I'm also going to tell you how much that equals per hour. I spent roughly, bearing in mind I was recording as well for each of the jobs, starting and stopping, it was around about 12 hours worth of work, essentially a full day and a half, without the faffing of all the equipment and making sure I've got the right angles, etc. Maybe I would have been able to get it down to a single day of 8 hours. So if we work it out for the selling one, so we do that and that. So this is what I earned per hour for the selling, would have been £35.22, and for the service, it would have been £32.08 per hour. Oh, bear in mind, I've not actually minus the £3 worth of parts for the service one. So take that into consideration as well. It kind of gives you a rough idea. A more consistent profit would definitely be doing this as a service, but I managed to get super lucky with the seller. This is basically unheard of on eBay. 95% of the Nintendo Switches I buy are in such bad condition. I was lucky enough to find a seller that I can trust, and I bought a bulk load of Nintendo Switches. I really hope you enjoyed this style of video, a little bit longer than usual and a slightly different format. I thought I'd add the service in at the end as well. Let me know what you thought of that down in the comment section down below. Sub and like if you enjoyed. Thanks for watching, and I'll see you in the next one. Peace.